Mindsetters, welcome to Learn Extra Live. I'm Katleho and today we're here with Hayley.
Hi,
Hayley will be
Mindsetters.
doing grade 10 maths literacy. Hey, Hayley.
Absolutely.
What's going to be up today?
Kateko, today we're going to be doing probability.
Okay.
And guys, I hope that you're all ready for it because I think it should be a fun lesson.
Yeah.
And yeah, so you tell them how to
Get
get
ready
hold of
for
us.
a thrilling lesson. I know we have lots of stuff to do today and lots of exciting stuff to do today. So I'm really keen for that. You guys know how to get hold of us. Facebook.com/LearnExtra, and our Twitter handle is @LearnExtra. I hope you guys are refreshed from school and have had some lunch and everything because this is going to be an awesome lesson, grade 10. Over to you, Hayley.
Thanks, Katleho. Guys, before we start, you know what we do first thing in my lesson every week is we look at our numbers. So we're doing probability, and let's go last week's numbers. And you know it was typed for me so nicely. Last week's numbers was 10702. What is today's number, Katleho?
11,041.
041. Yay, we got over 11. We should have had a party.
We should have had a party. We
Wish we could have a party every week. But what's the probability of that happening? I don't think very much. Okay.
Yeah.
Okay, guys, let's start with probability. I hope that we have some fun today. And I'm going to start by giving you some theory, just a little bit about probability. Then we're going to do some questions, and in the questions, I'll kind of go through a lot more theory with you. So, first of all, what is probability? So, let's just make a couple of notes. So, probability, I think I've left out a T.
Yeah.
Probability, okay, I can't spell, is the probability that something occurs. So we're looking at the probability of something happening. Something happening. Definitely not. Of something happening. And then we can discuss it in three different ways. We can discuss it as a percentage, we can discuss it as a decimal number, and we can discuss it as a fraction. So there are three ways. We can do it as a decimal. Yeah, I'm struggling to write today. Try that again. A decimal, a fraction, or a percentage. Right. So those are the three ways. So let's just briefly, I'm going to put the pen down even, discuss the probability of something occurring. So for example, Katleho, rain. The probability that it rains today. Did we see the weather today? Did you see the weather today?
I didn't, but I've seen the clouds out today.
Seen the clouds outside. So let's say that if we had seen the weather today, possibly the probability was, say, 30% chance that it would rain. That means that there's a 30% chance it'll rain. There's also a 70% chance that it won't rain. And when we're discussing rain, what's important to note is that this is in the catchment area. So they look at a particular area and it's basically, is it going to rain there? So sometimes they say, well, there's a 30% chance of raining in Joburg. Joburg's this huge area. The 30% is only one part. And I mean, often, I don't know about you, but I know I'm sitting at home and it's not raining by me, and yet at my mother,
Yeah,
it's raining.
And it may
So-
not even be far away.
And it's not exactly far away, 100%. But it's still, what is the chance of it happening? So I've got 30%. So that's just an example of a probability, 30% chance of rain. Let's now look at the probabilities in these three categories that I was discussing. So if I look at the numbers from 0, whoa, what a funny looking 0. 0, try that again. From 0, there's my 0, to 1. Hey, and I'm going to look at decimals. I'm going to start with decimals. I'm going to look at decimals in between. So the chance of something not happening is 0. So an example of that would be possibly if I had, I'm trying to think, if Ty was here. The chance of Ty falling pregnant, 0.
0.
0. Okay, so that it's never going to happen. The chance of something definitely happening is 1. So the chance that I am now teaching you probability and you are watching this program is a definite. It's happening right now, and that is 1. If we look at it as percentage, the chance of Ty falling pregnant, 0%, and the chance of me teaching you, 100%. So those are your extremes. And then we've got chances of things happening in between. So we can have a 0.5%, 0.5, or we could call it 50%. So the chance of it half happening. So it's either going to happen or not, but it's like a 50-50 chance. Well, that would be in between. And we've got numbers all the way to both extremes. I can write it also as a fraction. The chance of something occurring as 50% will be 1 out of 2. This would still be 0. Okay. This would still be 0. Get my pen again. Even out of a fraction and as a percentage. As a percentage, this would be 100%, and as a fraction, we could have it, say, possibly 2 out of 2. It could be 5 out of 5, but we're basically looking at a whole number of 1. So that's your fraction. Right, I hope that I've explained that well enough of things happening. But let's look at how we would write things as a fraction. So I'm actually going to go to the next page. I have another blank page here. How would I write my probability? Now, I could say my probability is actually my favorable outcome. That's what I want. My favorable outcome. Favorable outcome. I think I'll explain that in a little bit more detail in a second. Divided by my total outcomes. And can you see that that's going to give me a fraction? So let's do this with some examples. My probability of taking a coin and getting heads on a coin. Okay, I'm definitely having some interference with something here. No, it's not closing. Right, let's take a coin. Right, I have a 50-cent piece here. I don't know how well you can see this. I'm actually going to give it to Katlego. And we're going to see what the probability is. I'm going to pass that to you. Right, what are the probabilities of me dicing a head? Okay, or dicing, of me throwing a head. Now, what is my favorable outcome? That is the coin landing with heads showing. So that would be my favorable. How many possible outcomes have I got? I've got heads or tails. So I have 2 possible outcomes. So let's see what Katlego gets.
Must I just flip it?
Just flip the coin. Right. What does it land on?
Heads.
It landed on heads. Well, that's great. But what was the probability? Was in actual fact 1, because heads, there was 1 heads out of a possible 2. So that is my probability. Now, if I had to ask Katlego to flip this again and again and again, well, she's going to probably be cross with me after a while. But the reality is that the first time she got heads, which was kind of like maybe a fluke, but we will end up with like a 50-50 ratio. The more times we flip, she'll end up with so many heads and so many tails. And the longer we do this, the closer we will get to our half. Okay, let's look at a dice. Right, if I've got a dice has got 6 sides. So my possible outcomes on a dice is, total possible outcomes is 6. Now, what is the probability of me landing on a 1 on a dice? Well, how many 1s have I got on the dice? I've only got 1. So my possibility is 1 out of 6. And again, if I had to hand this to Katlego and she had to throw the dice, well, let's see that. Let's hand that over. Okay, let's see what she gets. Okay. 5. Okay, well, we have to do this over and over again. Eventually, we're going to get 1/6 of the throws that she makes will be a 1. So that's how we deal with probability. It is our favorable outcome. What do we want? Out of our total possible outcomes. So before we move on, I tell you what, let's look at some cards. But before we go to cards, I think we need to just discuss cards. So let's find some space here. So let's look at playing cards. And I'm going to show you the playing cards in a second. Right, what are our playing cards made up of? Our playing cards, we've got 4 suits. And I'm not going to be very good at drawing them. I've got hearts, I've got diamonds, I've got spades, and I've got clubs. So I've just dropped a card. So I've got hearts, diamonds, spades, and clubs. There are 4 of each card. Then I have 13 cards in each suit. I've got the ace, which is also a 1. Oh, let's make it a 1, to 10, as in number cards, with the numbers 1 to 10. And I also have a jack, a queen, and a king. So let me try to show you those to you. I've got a jack, a queen, and a king. Where's my king? And a king. So I hope that you can see those. So what have we got? We've got 13 of each, which basically gives me, let's look at the kings for a moment. I've got 4 different kings because I've got the king of hearts, the king of diamonds, the king of spades, and the king of clubs. And in each card, I have 4 of each. So 4 different suits and 13 different cards. In total, I have 52 cards. Now, I don't want you to panic that you don't know anything about cards, because what would happen in an exam or in an exercise, if you were given this kind of exercise and asked for probability dealing with cards, they would actually explain the breakdown of the cards. Let's now look at our probability of getting the king of hearts. Oh, not too bad a heart. Probability of me choosing the king of hearts. Well, first thing I have to do is get my favorable outcome. So my favorable outcome is how many kings of hearts do I have in a pack? Well, I only have 1. And how many cards do I have? 52. So that's the probability of me choosing the king of hearts. If I had to do what's the probability of me getting a king? Let's look at that probability. Now, in each one of these instances, I've actually put the cards back. So I've still got 52 cards. How many kings are there? Question is, there are 4 kings. Remember the 4 different suits? So we've got 4 kings out of a total possible 52 cards. And I can simplify that. I can leave it like this. And this is one thing with probability. You can leave your fraction the way it is. You can simplify it if you like, but be careful if they ask you for the percentage, or if they ask you to give the answer in a decimal form. So we can take our calculator and we can actually just type that into our calculator, 4 divided by 52, and we get 1 out of 13. And if they ask you for a decimal, well, it's 0.07. If they ask you for percentage, remember when we did percentage, we multiply everything by 100. So go back to my notes here, and I can simplify that as 1 over 13. Hey, and I can carry on doing this. Well, let's do one more. What is my probability of getting a heart? Well, my question is, how many hearts do I have? What's my favorable outcome? Well, I told you that there were 13 of each suit. So there are 13 hearts, and I'm dividing by my total possible outcome. That's how many cards do we have? So I've got 52 cards. I'm having a wonderful time with the board today. And I can simplify that as 1 out of 4. Okay, you can do that on your calculator. So that's working with probability. The hardest part of working with probability is actually working with finding the total possible outcomes. So that's really where the trick comes in to the question, and I will show you later on in the show how you can do one of those, how we can calculate the total possible outcomes. One more thing I'm going to show before I actually go on to the questions is I'm going to tell you, I'm going to tell you 2 things. First thing is we need to note that if we are putting the card back or not. So let's deal with our cards. If I had to take out the probability of getting a king of hearts, let's go back to my king of hearts, was still 1 out of 52. And now if I want to take out another card, a second card, and I want the probability of, say, the queen of hearts, I now have, how many queens of hearts have I got? I've got 1. But how many cards have I got? I've only got 51 cards left. So 51 cards is what's left. So my probability actually increases because I've got less of my outcomes, less of my total possible outcomes. And we need to look out for the words and. So if I want to know, and I'm not going to do the calculation because we'll see it in our work. If I want and, so if I want the probability of the king of hearts and the probability of a queen of hearts, then what I need to do is take my fraction of the king, my fraction of the queen, and in this case, when we have and, we multiply the two. But if I wanted either or, then I would add. So if I went to have, well, I wanted the probability of only choosing one card, and I wanted the probability of king of hearts, or the probability of it being the queen of hearts. In this case, my probability is still 1 out of 52. But remember, I'm only choosing one card, so my probability of the queen is still 1 out of 52 as well. And or we add. So it's slightly different to what you do. What kind of makes sense, I don't know how to put this, Katlego, but I know that normally when we think of and we add, in probability and we multiply.
No.
So it's different to what we used to. Or we add. So it's just the words that you need to look out for, those kind of words. Or you add and we multiply. That's just something to look out for when you're doing the questions. But the best way to actually conquer this is to actually do some examples. So I think maybe we should go on to question 1.
Yeah.
Okay, so let's do our first question. We're going to find our question. Right, we have a question. A bag has 5 apples, 3 pears, and 4 oranges. Find the following and express your answers as a fraction. So that's an important part. We need to express as a fraction. So what are they looking at? We want to know the probability of an apple is chosen. So what is how many apples? My favorable outcome is choosing an apple. So my question to you is, how many apples did we have? So let's go back and read. We had 5 apples. So my probability of choosing an apple is 5. Out of my total possible outcomes, that is my total possible fruit that I have in this bag. So how many fruit have I got? I'm going to do that separately, and I'll change the colors for a second. I've got 5 apples plus 3 pears plus 4 oranges. So add that up, I've got a total of 12. So let's go back to my pink, because I like my pink. So my total possible outcome is 12 pieces of fruit. And they said leave our answer as a fraction, so we can leave our answer exactly like that. We don't even have to try and simplify. What is the probability that a pear is chosen? So how many pears have we got? We've got 3 pears, and I still have 12 fruit in the bag. So my probability is just 3 out of 12. If you'd like to simplify it, we can. So that is a quarter. But the instruction didn't say simplify. And you won't lose marks if you don't simplify. So have a look out for that. What's the probability of an apple or pear is chosen? So I've got my apple was 5 out of 12. My pear was 3 out of 12. And I've got the word or, which means I need to add these. Now remember, when adding fractions, if your denominator is the same, you can just add the numerators. So we've got 5 plus 3 is 8 out of 12. And we can simplify that if you like. We can leave it as is. Let's do the last one. And then I think we need to take a little bit of a break. What do you say, Katlego?
Yes, let's do that.
Well, let's do the last
Let's do the last
question.
one, yeah.
So the probability that no pear is chosen. Well, I can do this in 2 ways. I can say, what's the probability of me choosing a pear, and then minus that from 1. Or I can work out the probability of apples and, what was our other fruit? Apple and oranges. So let's work out the probability of a pear, because we've worked that out already. Our probability that a pear was 1 out of 4. So probability that it's not a pear is we take our 1 and we minus our quarter, and we end up with 3/4. We should actually end up with the same answer no matter which way we do it. But we ended up with 3/4 probability of not choosing a pear. So it's important to just read carefully. But I think let's take a little bit of a break.
Okay, let's do that. So guys, you know the drill. Keep sending us all your questions and all your queries on what we have done, and we'll see you after the break.